My life was pretty shallow and carefree for the first 32 years. I partied and I chased girls, and I would consistently use phrases like math is stupid, and how does that math stuff actually apply to anything in the real world? Well, then in 2002, I had a brain injury, and it forever altered the way that I view reality. And at the time, I had no traditional mathematical training, so I had to learn to explain it in everyday, normal, layman terms. So before my brain injury, when I saw something move, it looked like it was moving smooth and was continuous. But after my injury, when something moved across my field of view, it looked choppy and discrete, like I was watching a video frame by individual frame, only in real time. And I was amazed to realize that our brain constructs a moving image much like a video or an old-fashioned flip book. You know those old flip books where you flip pages and where you write a character on each page, and as you flip the pages, it looks like the character moves, only the character moves jittery. Well, when our brain constructs a moving image, it's just like that, only our brain smooths the images out for us so that they look fluid and uninterrupted. Well, after my injury, everything did not look fluid to me anymore. In other words, that fluidity of motion was gone. When something moved, I was extremely aware of the picture frames. If something moved fast, the picture frames were further apart. And if something moved slower, the picture frames were closer together. And the rate that the picture frames changed relative to the speed of light was their velocity. And it also gave everything a slightly pixelated quality. It's like everything that is moving relative to a matrix or a grid structure, like pixels on a television screen. And so what seeing things this way did to me mathematically was, it was absolutely stunning. It made me see that to define motion around me, all I had to do was look at two different moments in time, two picture frames, and then I would compare the differences and what the changes were between them. And if I made the picture frames closer together, or the time intervals smaller, I would get a more fluid and continuous view of reality. And being forced to see this way started me thinking, if I am seeing picture frames, then somebody else in a different position and moving at a different velocity relative to me, I wondered, did they see the same picture frames that I saw? Well, it was questions like this that forever changed my view of reality. And the way reality actually worked turned out to be much richer, far deeper, and more science fiction-like than I ever could have imagined. And one of the biggest revelations I had when I was thinking about motion was that an object's motion, when it moves, its total motion through space and time always equals exactly the speed of light. And space and time are so intimately connected, so interwoven that they truly cannot be separated, which is why Einstein coined the phrase space-time. Plus, everything in the universe displays wave-like behavior, even time itself. Even us, we're waves, and every sense that is evolved is dependent on waves. Sight, sound, taste, touch, smell, the sense of magnetism in animals, they're all dependent on waves. For instance, if we smell something, it's believed by many that we are not only detecting the shape of the molecule, but its vibrational frequency. When we feel something that's hot or cold, the reason why it feels hot is because the molecules are vibrating faster. And if it feels colder, it's because they're going slower. So cold really doesn't exist. Cold is just less vibration, so it's just less heat. When we hear something, we're dependent on sound waves. And when we see something, we're dependent on light waves. And what's so amazing is that waves change based on the position and the velocity of the observer and the observed. I mean, right now, all of us, we are waves as we travel through space-time. For instance, everything, including you and this building and the planet, we're all vibrating at a certain frequency, and we're all moving through space. So as you vibrate and move, you're making a wave through space. So here we all are, vibrating, sitting on the planet Earth, which is vibrating as it moves around the sun, which is vibrating as it moves around the galaxy. So we are literally a wave within a wave, within a wave, within a wave. So it's pretty amazing stuff. And But what is really amazing is that all waves are subject to the Doppler effect. So when we think of things like alternate realities, parallel universes, or relativity, it's really hard for many of us to actually believe that this is something that's real. I mean, my shirt's blue, right? It's not blue and red and green, at the same time. If I were to sing a note right now, I would be singing that one note. I wouldn't be singing all notes in existence. But actually, my shirt is every color. And if I did sing a note, you could say that, yes, I am singing every single note in existence. And here's the best way I can think of to describe it. There's something called the Doppler effect, and it describes how waves change based on motion. And so we've all heard a car drive by us. And you know how a car drives by us, it goes, and it changes pitch? The reason it changes pitch is because short wavelengths of sound, we hear that as a high pitch, and long wavelengths of sound, we hear as a low pitch. So as the car is moving towards you, or towards me, that sound wave is getting kind of squished together as those wavefronts get closer, and I hear the pitch getting higher, and then the car goes vroom, and the pitch gets lower as the car moves away from me because those wavefronts are stretching out and getting further apart, so I hear the pitch getting lower. But now, if we add relativity to it, and we say that the car is moving away from the person on the left and towards the person on the right. Well, relative to the person on the left, the waves are stretching out and getting longer, so that person hears a low pitch. But at the exact same time, the person on the right, the waves are compressing and getting closer together, they hear the pitch getting higher. And the person in the car, they're traveling with the sound source or with the wave source, so they hear a medium pitch and no sound change at all. And then what you do right there is you stop and say, what sound is the car actually making for real? It's kind of a weird question, but yeah. Is it making a low pitch to the person on the left, a high pitch to the person on the right, or a medium pitch to the person in the car? And it's actually making all three sounds relative to who's looking at it. And then you say, imagine there's an infinite number of people, and they're all looking at that car, and they're all moving at different velocities. Every single person hears a different sound, and every single reality is real and valid. It's just that they're relative. And so you know that old question of if a tree falls in the forest and nobody's around to hear it, does it make a sound? It doesn't. It makes a wave, and only if something's there with sound receptors does it make a sound. And so this same idea applies to light. So we all look at my shirt and we say, my shirt's blue, right? So you think we can see where this is heading. So we say my shirt's blue, but blue is a short wavelength of sound, and red is a short wavelength of light, and red is a long wavelength of light. And so if everybody in the audience had a twin, and your twins were up here with me, and we shot away from you at close to the speed of light, the wavelengths of light would stretch out and get longer, and all of you would see my shirt change to red. But your twins in motion with me, they would see my shirt as blue. And then again we ask, what color is my shirt, red or blue? And it's literally both. And then we take one step further and we say, now imagine there's an infinite number of people all looking at my shirt, and every person's moving at a different velocity. Every single person sees a different color, and every reality is real, even though every reality is different. And so every single moment has the potential to literally be anything. And every potential can be any reality. It is just the slices of space-time, the picture frames that you realize that become your reality. But all the other realities that you don't see, that you don't experience, they are all just as real. It's just that by you, they're unrealized. Thank you. Thank you.